Welcome to Python Basics with EJD. In this video, we're looking at Python variable scope. We first mentioned these under Python functions, knowing that variables have their scopes in Python, right? Some very like so far we saw global and local variables, and we saw that local variables are variables that are defined outside of a function, while local variables are defined within functions. So global variables can be called within a function, even where they are not defined, or elsewhere, in the whole process. While local variables can only be called, they can only be used within the function in which they are called. Now, and we also saw that to make a variable global, even when it is called within a function, we need to use the keyword global, right? So let's go ahead and see in some more depth uh what variable scopes are in Python for sure. Okay, so we move on to variable scope, Python variable scope, Python variable scope. Yeah, so here we have it. Variable scope defines where in a program a variable can be accessed or modified. Okay, so Python has a well-defined hierarchy of scopes that determines variable visibility. In the function thing we saw before, we only saw two levels of scope, whether it's local or global, or here we're looking at more elaborate scopes. So basic concepts here, we have variable. A variable is simply a name that refers to a value stored in memory. In lesson 5, I believe, in one of the early lessons, we saw how to name variables in Python, right? Knowing that we don't start variable names with numbers but we can start with alphabets, and then we can end with numbers. We can have numbers in between, and then we cannot have spaces in between variable names, things like that. So we did that earlier. So a name that refers to a value stored in memory is called a variable. Then we have the scope. The scope is the region of a program where a variable is recognized. So like I said, a global variable is recognized everywhere, while a local variable is recognized only within a function within which it is defined. Then we have a lifetime. Lifetime talks about how long a variable exists in memory. So the lifetime of a variable is how long it exists in a memory. A variable can be overwritten. If I say x is equal to 5 somewhere, and I go to a cell after it and I say x is equal to something else, so that new value of x automatically overwrites that value of the x when it was 5, right? So the lifetime of a variable is how long a variable exists in memory. Now let's look at types of scope in Python. Types of scope in Python. Okay, so before now we knew just local and global, but now we have even more. So Python uses the LEGB rule, which stands for L for local, that's local scope. Variables defined inside a function, those are local variables, and they are only accessible inside that function. After that, we go for enclosing scope, which are variables in the outer function. If functions are nested, we saw a couple of nested functions, in when we talked about in the last video where we talked about advanced Python functions. So variables in the outer functions, also they are, if functions are nested, so they are accessible inside nested functions, right? Then we have the global scope. These are variables defined at the top level of a script or module, accessible everywhere in that module. So if you open a session like this session now, once I say x is equal to 5, not within a function, then I can access it everywhere else in this session, in this module, like this. Then we have built-in scope. So names, these are names predefined in Python like print, len, int, and they are accessible anywhere also. So these are built-in scopes in Python. Okay. Now, let's talk about the local scope. Like we saw in the video under Python functions. So local scope talks about variables declared inside a function, and they only exist while the function runs. So once the function stops working, the variables they stop existing. So they only exist while the function runs. A good example is this. You have define greet, message is hello world. So this hello world now, this message variable is actually a local variable. We cannot access it outside of this function. So if I say greet now, of course, it's going to just say hello world. So if I greet now, it says hello world. Of course, as you know, the first time we run a code in Google Colab, it's slow. Yeah, so this gives hello world. But see what happens here. What if I now say print message, right? You know that message is actually a local variable inside this function greet. So if I run it now, say print message. So you see, name message is not defined because it was defined within a function and it cannot be accessed outside of that function. Okay, that's the idea of a local scope. Okay, now let's talk about an enclosing or non-local scope. So this occurs in nested functions, like we said earlier. So these are variables in the outer function. Variables in the outer function are accessible in the inner function, but not directly modifiable without non-local. So we need to use non-local to make it accessible. So variables in the outer function are accessible in the inner function, but not directly modifiable without non-local. So if you want to modify, we need to make them non-local. I think we had that kind of example in the last video. So imagine we have a function, uh, define outer, okay, and you say name Alice. This is your so this name now is the enclosing variable because it is in the outer function. So the outer function is the first function. The inner function is this next function that is indented under the outer function. So you now define an inner function which says print hello, whatever name you supply. So you can now access this name Alice inside the inner scope. So you can access enclosing variable right here. And then of course this one ends with the inner, meaning that you are calling the inner scope, which is to say hello of a name, but the name is not available. But the name is now picked up from the outer scope. And then by the time you run the outer, you just say hello, Alice. Whatever name you supply, you have that right there. So inner scope. So in a nested function, the inner function can access the variable in the outer function. That's what this is about. So we can also modify enclosing variables, right? For instance, you have define. So to modify enclosing variables, that's what we're saying, that you have to use the non-local keyword. You can see all these things in blue are actually keywords, right? Define outer, counter is 0. This is initialization. So you now define the inner non-local counter. So if you want to modify this counter now, because it is in the outer function, you need to use the non-local. So part of modification is you trying to say counter plus or equals 1, because each time it comes here, the counter increments by 1 and takes the new value. So you have, it was 0. By the time you come in, you have counter plus 1. That's 0 plus 1. So counter is not equal to 1, and then you can print. So you now have the inner, and then by the time you go to the outer, you can have that as 1. So I think if you even run it again, so you see, that's inner twice. So what if you run it again? Let's see. Okay. Now it's no, it's, oh, okay, outer. I think I should close. Yeah. So you see 1 to 1 to again. Okay. So that's what we have in that situation. So, you see, non-local allows functions to modify enclosing variables. So if you want to modify enclosing variables, like a function in an outer function inside the inner function, if you want to modify that, use non-local, like we said. So without non-local, assigning to counter would create a new local variable in inner. All right. So if there was no non-local here, so this counter here will be seen as another counter entirely different from the one in the outer. Okay. Then we talk about global scope, which is what we are used to the most. In fact, this is the most common variable type we'll be using because you just declare it and then you can use it anywhere. So global scope, variables declared outside all functions. So it is accessible inside functions, and that is read only by default, and it is modifiable inside functions using global. So if you want to uh, you know, modify a global variable inside the function, you need to use the global keyword. Just like if you want to modify an outer function variable inside an inner function, you need to use the word, the keyword non-local. But for global scope, if you want to modify it within a function, you need to use the word global. All right. So imagine you just say x is equal to 10. That's a global variable. It's open to be used anywhere in this Excel sheet. If I go to the back and I say x plus, okay, let me even demonstrate that. If I go to the end of this whole thing and then I just create something. I just say y is equal to 77 plus x. So it recognizes that x, okay, because I've not defined x, right? You know why it's saying I've not defined? Because I've not run it. That's the deal. So if I run this now, okay, so x is equal to 10 global variable. So define show print x, which is 10. So I just say show. So it prints the 10 because it was defined as, but it can be accessed within this, and then it can be accessed anywhere. That's why it's called global. So if I come back here now that I've run it, it gives me oh, okay, I didn't say it should print. I just say print y. Okay, print y. It gives me 87. So imagine it was declared way up here, but as far as I've not called another x, that same x remains. So in this case now, so next we can see that we can modify global variables inside functions. So now, if I say x is equal to 5, automatically, number one, this x that was global before, this new x overwrites it automatically. So okay, let me even say, so imagine if I print x now, okay, if I print x here, let me even carry this function to another place. I want to show that, um, here x was 10 up till this point. But once you say x is equal to 5, it automatically overrides the previous one. So I say control enter. So x is now 5. So if I now define a new function, I say define change global. So the x that was 5 before, and I want to change the global. So I say global x equals 20. So that modifies global x. So now the new value of x will now be 20 because we have used the keyword global, though it is within a function, but we have used the keyword global. So it will overwrite the 5 now that we now have. So by the time you change global and you print x now, you get 20. But then there's a caution. Excessive use of global can make code harder to debug. So if you use a lot of global, that can be a lot of trouble. So it's better you don't use global unless it is absolutely necessary. Then we have built-in scope. Okay. So built-in scope contains names predefined in Python. Examples include length, print, sum, max, and they are always accessible unless shadowed by a local or global variable with the same name. So if you now have a global len, it can override this, but it's advisable you try avoiding built-in names for function names. I think we've said that already, that you should avoid Python keywords as variable names. So imagine if you have len equals 5 and say shadows, this shadows built-in len function, right? Because we have said len is equal to 5. So if you now say print len, it's going to print 5 actually, right? So let me remove this so that I can run it in the next cell. Okay. Okay. So because len 5 has been applied to len, it prints the 5 because now by declaring it this way, we are overwriting the other len. So but there are some keywords you can't even use. If I say print is equal to 5 and I say print, but now say print, does it work? Okay, I think it works. Interesting. It doesn't work because it's not callable. So let's leave it. But len, in the case of len, we could still use that. Okay. What's happening here? Len is 5, built-in len function. Okay. I don't know what's wrong here. Okay, I'll just move on. So let me do this other one. So now print len 1, 2, 3. So in this case, we have print len 1, 2, 3 error. Len is now integer, so not function anymore. So we cannot, so it's going to give an error in this case because we had run it the first time. I think that's why this error is even coming up because it has been done to an integer. All right. Okay, I think I'll just go on. No worries. So avoid redefining built-in names. So don't redefine built-in names. It's not advisable at all. So let's look at scope hierarchy and lookup. So what are the levels? Like we've seen before, Python searches for a variable in the following order. It looks for a local variable. If it doesn't see that, it goes for an enclosing one. If it doesn't see that, it goes for a global one. If it doesn't see that, it goes for a built-in one. So that's the LEGB rule. For instance, if you have X is global, so I say X is the string global is attached to X. Then I now define outer and I say X is enclosing. All right. And I define inner and I say another X now is local. And I print X. It finds the local first. And then the inner, it prints X. So it finds the enclosing. And then you have the outer, which finds the global. So you see, X has been defined as different things. X is global first, then enclosing, then local. So and how it goes is local, enclosing, global and then built-in, but we don't have built-in in this case. So the hierarchy is finds local, then after that it goes enclosing, then it goes global finally. So at the end of the day, this tells us, okay, I guess I have to restart this thing. It's giving me attitude like they say. So I'm going to restart the session. Yes. So I'm going to start as if I'm just starting afresh. So I have this. Okay, this goes. Then here, of course, this is expected to be an error as usual. Then here I do the Alice thing. Then here I do the outer thing, 1, 2. Then here I do this, 10. Then here, this is 5. This is 20 as expected. Then that length thing, at first it's run. So if I do it again, it's going to give an error as expected. All right, that's where the whole thing started. So here now we have all the global. So if you run it now, so so if you print X, it goes first, it looks for the local, then it goes for the enclosing, and then it goes for the global, right? So that's what we have right there. So the global and non-local keywords, like we've seen already, so the global and non-local keywords, global allows modification of global variables inside the function, and non-local allows modification of enclosing outer function variables like that. So we can have an example combining both. You have x is equal to 1, that makes x a global variable. So define outer. If you now say y is equal to 2, so this y equals to now is local to the function outer, but then it can be accessed in the inner function. So if you now say global x, so it automatically makes this X now that is global. It now, we can modify it inside of inner, but that's why we can say X plus or equals 1. Without the global, this line 8 won't be possible. Then this Y equals 2 is for outer, but if you want to modify it, you can call it inside in the inner function, but you cannot modify it. So you need for modification, that's why you need global for global variable and non-local for variable for the outer function, right? So the non-local is why we can now say y plus or equals 1. And then we can now print inner and we say xy and outer is y. So if you print all that now, you say inner is 2, 3, all right? Because of the incrementation that would have happened here. So x before was 1, right? So because of the global, so x plus 1, that 1 plus 1 is 2. So the new value of x is 2. So because we are printing xy, so we have 2, and y is 2 in the outer function. But because we have used non-local, we can modify it to 3. So that's now 2 plus 1, 3. So y is now 3. Then the outer, so in the outer now we have 3, and in the global we now have 2, like that. So we can also have variable shadowing, okay? A local variable with the same name as a global or enclosing variable hides the outer variable within its scope, right? So you have x is equal to 10, right? And then you define x is equal to 5, which is a shadow global x. It's a shadow global x. So if you print x now, it's going to give you 5 in this case. But if you print the function, you get 10. I mean, you get the 5 that was defined inside the function. But if you print a general x for global x, it remains 10 that it is. So this function is printing this x that this function says it should print. But this print x is normal, is a general statement. It has nothing to do with this function. Maybe I should even take it apart, right? So if I run func, it gives 5 because that function is supposed to do 5, right? Then if I now print a general x, it gives the 10 that was global before. So it is localized to that function. Then we can also talk about scope in classes. Of course, we've not talked about classes. Very soon we'll be talking about object-oriented programming. That will be defining classes and things like that. So variables in a class can be instance variables like self.var. So these are instance variables and they are local to the instance. Like in this case, now when you have self.instance underscore var, that's an instance variable which is local to the instance. And you can have class variables that are shared across all instances. Okay, so you have class my class. This is when we get to object-oriented program, you understand this whole class thing. So class my class underscore var equals 0. This is a class variable, right? But then if you define an instance, so you define double underscore init double underscore self. So self.instance underscore var equals 1. That's an instance variable now, only available to the instance. It's more like localized. Then if you have object 1, my class, object 2, my class. Then if you now have object 1, instance var equals 5, and object 1 class var equals 10. So you can now call this now, and you have all these things. So you have 5, 10, 1, 0. When we get to talk about object-oriented programming, we'll have a clearer understanding of all these instances, inheritance, and things like this. So practical guidelines: avoid excessive global variables. So if you don't want, if it's not absolutely necessary, don't use the keyword global, right? Then use local variables when possible, which will just localize your function. Then use non-local for nested function modifications. Then don't shadow built-ins. That is, don't use built-ins. Don't overwrite them, basically, like we did for learn the other time. Then understand LEGB to debug scope errors. That's local, enclosing, global, and then built-in. That's the order. So in summary, we have our scope. Local is inside a function, and it can only be accessible inside the function. It's not keyword. So enclosing is outside function in nested functions, and it can be accessible uh, in inner functions, and you can only modify using non-local. Then global is top level of module, and you can use anywhere in the module. And the keyword, if you need to modify, is global. Then for built-in function, these are Python predefined names, or what we call keywords. They're accessible anywhere. All right. So now you see, the other time I ran y to be 77 plus x. Now, if I run it again, the answer may not be 87 because the value of x has changed a lot. So if I do this now, okay, it remains 87. Lovely. Okay, so nothing has changed. So with this, I come to the end of this interesting video talking about variable scope in Python. And I think one thing to take home here is the LEGB framework, right? The local, enclosing, global, and built-in rule. That's really important. Okay, that's key to what we have done so far. So let me know how helpful this video is for you. And if there's something you'd like me to try out, feel free to let me know. If you have not subscribed already, of course, you're missing a lot. So if you have subscribed, please, thank you very much for that. And if you have not subscribed, please go ahead and subscribe. Hit the notification bell so you can always get alerted each time a new video is released. You can take it a step further, become a member of the channel, right? And that comes with some special privileges for sure. So you can click on join, and you see all these levels of membership that are available to you. Then of course, don't forget to like, share, comment so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.